Hi Professor, it's me Jeevan. This is my video demonstration for CLO835 assignment 1. Today I will demonstrate the full life cycle of deploying a containerized two-tier web application on Amazon AWS EC2 from infrastructure setup with Terraform to CI/CD with GitHub Actions, and finally deployment and verification. First, this is my GitHub. uh, Here I have forked the provided application repository, and also I have created a new empty public repository on GitHub where it hosts all my infrastructure as code. Now, here in my Cloud9 environment, I have both repositories cloned, that is CLO 835 application, you can see that, and CLO assignment 1 Terraform for the Terraform. I have also generated the SSH key pair, this one and this one. Now let's provision all our AWS infrastructure, including application load balancer, using the Terraform. uh, Here I have created the configuration files, that is main.tf. It includes two ECR repositories, security groups, um, EC2 instance, application load balancers, and target groups, as you can see. And I have variables.tf configuration file and output.tf file. Now I will initialize the Terraform, plan the deployment, and then apply the configuration. Let us go to the terminal. Here, Terraform init. Initialization is successful. Terraform plan. It is successful. Now Terraform apply auto approve. Now the Terraform has completed the deployment, providing us the with the ECR repository URIs, EC2 instance, public IP, and the LB names. Now let's go to ECR. ECR. Here is our assignment CLO35 assignment 1 app and DV ECR repositories. Now let's go to EC2. The generated key pairs. Security groups. Let's go. Security group. LV security group and CLO35 assignment 1 security group. Let's go to instances. The new instance has been launched. Now let's go to load balancer. Load balancer, as you can see, load balancer has been created, and there are 4 listener rules. You can see there are 4 listener rules, and this will forward it to the target group. There are 4 target groups. This is for blue, pink, and lime, and if nothing is found, then it generates an error response. Next, as we prepare our application for containerization and verify it locally, I have made some changes to these files, because there was some import error type error as well as such as db port missing. So I changed to these files, and after building our docker images and running them locally on custom docker network, our flask application is successfully serving the content, as you can see here. Now I'll show you it from the locally running browser. As you can see, I can see the output. This is working well. Now I will be committing all the updated code to my GitHub repository. That will be ready for the CI/CD pipeline. Now for GitHub Actions CI/CD for Docker images. Let me go to my GitHub. Let's confirm our GitHub setup. In my application repository, as you can see, our main branch is protected, requiring pull requests and status checks. As you can see. Now let me go to the secrets and variables. Secret and variables actions. All our AWS credentials and ECR repository URLs are securely stored as GitHub secrets. Now let me go to my workflow. My main.yml file. Here our main.yml workflow is configured to build and push Docker images on pushes to the main branch, as you can see here. Now to simulate a code change that will trigger our CI/CD pipeline, I'll make minor changes in app.py. Let me change 1. Let me save it. Now I'll create a new feature branch, commit this change and push it to GitHub. Let me git free git commit sym trigger GitHub actions. Git push origin dev dash trigger 3. Sorry, flow. It's done. Password is done now. Now back in GitHub, I'll create a pull request from our dev workflow trigger branch into main. GitHub, let me go to the pull request, compare and pull request. Let me change the base to ancestor. Create pull request. Now this has been, all checks has been passed. Click merge pull request. Merge. Successfully done. Now let me go to the actions. As you can see, merge pull request from this is successful. Finally, let's verify that the new Docker image has been successfully pushed to ECR. Let me go to ECR. Assignment 1, as you can see, shows the latest tag and its last push timestamp. Similarly, let me go to H1 here. latest, and you can see the timestamp. Both our web app and MySQL images are now updated in ECR, confirming our CI/CD pipeline is fully functional. Now for EC2 container deployment, I proceeded by deploying our containerized application on the EC2 instance. First, I securely connected to the EC2 instance from Cloud9 terminal using SSH key. I'm successfully connected, and then I use the credentials to log into the ECR from the EC2 instance. I'm successfully logged in. Then with ECR authenticated, I pull the latest Docker images for both web application and MySQL database. As you can see, both are successful. Since the pull was complete, Docker images show that we have two images, database and web, one for database and one for web application. Then to enable secure and name-based communication between our application and database containers, I created a custom Docker bridge network. You can see here. Then I launched our MySQL database container on this network with this code. As you can see, it's generated. Then to confirm the database container is running and correctly initialized, I use a temporary MySQL client container to connect and list the database and tables. As you can see, the tables that we have. After this, I launched 3 instances of our web application. Each instance will has a different background color and exposed on a unique host port, and they will connect to our MySQL container on the employees database using port 3306 through our custom network. These are the 3 web applications. Now let me run docker ps. Here it successfully shows 4 containers: MySQL DB, blue app, pink app and lime app. Since now everything has been set up, we will confirm our applications are reachable directly via the EC2 instance public IP address and on their respective ports. For this, I'm going to my web browser and pasting this link for 8081. It's for blue app. For port 8082 is for pink app, and for 8083 it's a lime app. Thus this confirms and shows that all of them are running and directly accessible. Now this is my second attempt. As my environment got reset, I got some error and I had to redo it again. I'm doing this recording only specific to the DNS and pinging. Now let's confirm this application are reachable by the application load balancer. Let me go here. I have already pasted the URL. I have already pasted the DNS. This is the LV DNS name. Now for blue, as you can see, for blue it's working by ALV. Now for pink, it is working for pink, and now for lime, it is working for lime as well. Now I'll demonstrate that containers can ping each other using their host names within our custom network. For this, I have already as you can see, the pinging for this one is successful. Now for lime, also for this it's successful. Thus the blue app can successfully resolve and ping both the pink app and lime app by their container names. This is because of the Docker's built-in DNS for custom bridge networks. Now let's discuss why you can run three applications listening on the same internal port 8080 on the single EC2 instance. Let me first run docker base. Each Docker container runs in its own isolated network namespace. So internally, each of our blue, pink, and lime application container is independently listening on port 8080 without conflict. Then the EC2 host machine uses the Docker port mapping to expose these internal container ports to different unique ports on the host machine, that is 8081, 8082, and 8083 respectively. Our load balancer then uses these unique host ports to forward traffic based on the URL path. Thank you. This is all my video recordings for this assignment 1. Thank you.